pleasant part about it. So my name is Alina. I'm GraalVM developer advocate at Oracle Labs, and that's what we'll be talking about today. So we'll talk about what GraalVM can offer for you, what are the components, the architecture, what's inside, and when should you start, what to look at if you have some specific use case you would like to use GraalVM in. Let's begin. So yeah, this is our agenda for today's talk. First, we will talk a bit about what's under the hood, the architecture, the components, how they are working with each other. Then we will talk a bit about performance optimization, because first of all, we all like our applications to be fast and productive. And second, as Chris mentioned during the keynote today, that has some bigger, impact, not only in our organization, but for the environment around us. Then we will talk a bit about fast startup. So this is something GraalVM is particularly popular for. So the ability to compile the application down to the native code, which can start really fast and will be no longer dependent on the JVM. Then we'll talk a bit about industry use cases of some companies who already are using GraalVM and what is the results that they are getting. And in the end, I will talk a bit about what's coming next. So we are working on our future releases, and we'll talk a bit about what will be in those future releases. Let's begin. So this is a funny tweet I saw recently, and this was some guy describing like what GraalVM looks for him from the outside. So it basically says that Java-C is one Java compiler written in Java, and GraalVM is another Java compiler written in Java. And you can use this one Java compiler written in Java to compile another one to native code to boost its performance. So I don't know how about you, but to me it sounds a bit like, this Inception movie with Leonardo DiCaprio, where, there are dreams and things are layered like this. So this is a bit how it looks from the outside. From the inside, on a more serious point of view, so why GraalVM? Why are some people talking about it? Why should you care, and what's in it? So first of all, it can offer high performance for your applications, meaning they will be running faster. They can reduce less. They can use less CPU, reducing this environment issues. Second thing is that we can provide fast startup for Java applications, because they will no longer need JVM to run, meaning they can start really fast, because the only thing that will be in the resultant binary is your actual application code. So no unnecessary code, no infrastructure that would be normally needed to load classes, to optimize code, and so on. Another aspect is polyglot. So maybe you have heard that GraalVM supports different languages, and also it supports smooth interop between those languages. So they can interact with each other really fast, and you don't have to handle on this logic on your side. And the last but not least, and this is something that I particularly like a lot about GraalVM, is that it has open source version. So our development is on GitHub. You can track the progress, see what's coming soon, what are new features that are coming, maybe contribute also if you see some particular feature or some, for example, language that you would like to be on the GraalVM platform. So in a nutshell, this is like the most generic overview of GraalVM capabilities and features. So on the top here, you can see languages that GraalVM supports, and below are the platforms where you can use GraalVM. So going a bit into more detail, so first of all, we can run your normal Java and JVM applications. So if you have your Java applications, which you normally run, let's say, on Java 8, you can just as well use GraalVM, just download it, change your Java home to point to GraalVM, and use it in the context of OpenJDK. Obviously, it's fair for Java, Scala, Kotlin, whatever language you are using. By the way, are you guys mostly Java developers? Yeah, can it be show of hands? What about other languages like Scala, maybe? Okay, a few people. Kotlin? A few more. Okay, nice. So that is something where you can use GraalVM to run your applications. Talking about other languages, that could be, for example, JavaScript and Ruby. Talking about JavaScript, we are keeping it to the latest ECMAScript standard, so it's fully compatible, and also we constantly test against thousands of NPM packages to make sure that our JavaScript engine is compatible and you can run your applications and be sure about them. Also, you see R and Python here. So, for example, if you are doing something like, statistics, data visualization, machine learning, and so on, you can use GraalVM for it. And the last one here is C, C++, so basically all LLVM languages, you can run them on GraalVM too. Talking about platforms, so I talked about OpenJDK a bit. The next one is Node.js. So if you have a Node.js application, you can run it on GraalVM as well. And one interesting use case here also is a database. So for example, you can embed GraalVM in your database. And the reason to do so is, for example, that you can use some other language, like let's say JavaScript. You can have on your front-end part, you can have some JavaScript logic, for example, to validate whether something is email or not. And you can have the same ability in your database and do the same logic in your database. And the last mode here is standalone, so those are the native images that I've talked about before. Production ready. So the exact organization where I work is Oracle Labs, and this is an R&D organization. So we do a lot of research, and GraalVM was a research project like this too. And it's been a research project for 8 years. Also, later for a year, we've been pushing out release candidates. And as of May this year, we introduced our first production-ready release, which was GraalVM 19.0. It was a huge milestone for us. And by the way, it was presented here in London too. So it's nice to be back for our team. And currently, the latest release is 19.2 because we constantly add some new features and new capabilities. So from the inside, it looks like this. So in the context of OpenJDK, the platform below, you see it's your normal Java hotspot VM. And what is different compared to like your normal Java distribution is that there is additional compiler plugged in, which is called GraalVM compiler. So it is an external compiler, and you can use in your Java external compiler and, for example, compare the performance of how GraalVM compiler or any other tutor compiler will perform against C2, and we will see a demo of that in a bit. On top here, you see a language implementation API. So that's that polyglot ability that I mentioned. That's something that allows you to run all of these different languages on GraalVM platform. So there are some of the languages supported by our team, and just as well, you can also implement a new language. For example, if you have some language you are working on and you need a platform for it, you can implement it and benefit from the access to the other capabilities that GraalVM offers. For example, there is an interesting use case for it. So if you know Goldman Sachs, this huge investment finance company, they have their own in-house programming language developed something like 25 years ago. And they're currently bringing it on GraalVM platform to get access to the development tools that are inside. And one more new thing here is Sulon. So this is our LLVM interpreter. That's our way of running LLVM languages on GraalVM. So we also have a website. So if you would like to try it, if you would like to read more about it, if you would like to ask a question, that would be a nice starting point for you. There you can get downloads, and currently we have our builds based on Java 8, and we are working on Java 11 based builds. Also there you can read all the documentation for various use cases, and also there are links to our community channels where you can ask a question. For example, if you are facing some issue, if you don't understand something, so there is a possibility to ask. Talking about downloads, we have 2 editions. The one I mentioned, open source edition, is called Community Edition, and there is also an enterprise one, which requires license to be used, but also it is free for evaluation purposes. So you can download it, you can try it, you can measure the performance, you can evaluate performance as long as you need, because sometimes it is a long process, and only when you decide to move into production, that's when you need to get a license. Once again, about the performance part, this is an overview of all our repositories. So overall, we maintain over 3.5 million lines of code in open source. We have a huge team working on it, and this is like an overview of, there is a core repository, language implementation, tools like VisualVM, and so on. So talking about performance optimization, if you would like to measure or define performance, the first thing that would perhaps come to your mind is peak throughput, right? So when your system reaches its steady, warmed-up state, how many operations per second can it handle? That's a very common definition. That's something that you perhaps could think of. Another one can be reduced max latency, so you can care a bit more about making sure that some certain requests are handled in the reasonable amount of time. One more, which is maybe not so obvious, can be startup time. So sometimes there are cases where you care about peak performance less, but you would rather care about, starting something fast, getting done, finishing it, moving on to the next thing. So that is the case when you can care about startup performance more. And one more can be memory footprint. So for example, if you are dealing with cloud environments and if you are being charged for memory that your application uses, being able to cut that resources usage would mean that you can save some money or, for example, do more with what you currently have. And the last one aspect you can think about is less relevant perhaps for server-side environments, but it can be more relevant, for example, for those who work with mobile devices where the resources are more limited. So this is the packaging size. So for example, if you are developing some application for a mobile platform that your user will download it and use it. So from user experience perspective, if it will be, let's say, twice smaller, they will be more likely to download it and to keep it. That could be one more dimension to keep in mind. So talking about just-in-time compilation, here is the priorities and the trade-offs that just-in-time compilation offers you, right? So with just-in-time compilation, you get great peak throughput, you get great latency metrics, but you trade off a bit in terms of startup performance and in terms of memory usage, because you need to carry all of that infrastructure that actually provides you just-in-time compilation capabilities. That is something that Java is particularly known and loathed for, right? So peak performance is something where Java is very good at. If you think about things in slightly different ways, so for example, if you care about startup more and resources usage more, AOT compilation, ahead-of-time compilation, can be a right answer for you, because the trade-off would be slightly different here. So if you prioritize startup time and memory usage over things like peak throughput and reduced max latency, that could be your choice. Because if you need just something, started fast and done fast, and you don't really care about what happens later because your work will be actually done in those first, minutes, seconds, that could be a choice for you. And now into the just-in-time compilation. So when I mentioned that you can compare GraalVM compiler to C2 compiler, that there is one demo that I would like to show you. Okay, what's happening here? Excuse me, I don't know what's happening with my screens. Okay. So I have this stream benchmark, and I will show you what it does in a second. So I will run it with GraalVM. Let me just double check it. Yeah, so you see, why didn't I tell you? Don't see that screen. Okay, so it's over here. Let me just pull it a bit above so the guys on the back can see it. Can anyone see what's going on there, back there? Okay. So yeah, I've checked my Java version, and it points to 9.201 GraalVM Enterprise Edition. So what I can do here, I will run it with a command like this. So as you mentioned here, I disabled GraalVM compiler, meaning I will be using kind of regular Java 8, because without this compiler, it will be a normal Java 8 hotspot VM with a C2 as a top-tier compiler. And what is actually going on here is this benchmark. So you see it's pretty simple and straightforward. We get a bunch of ints. We perform some map operations on them. We reduce it over here. And we do this for 1 iteration of warm-up and 3 iterations of the actual measurement. And what we'll be measuring is nanoseconds per operation, meaning lower numbers are better because we will consume less time for each particular operation. Let's see what's going on there. So it's complete, and here it is 172 nanoseconds per operation. Maybe it's fast, maybe it's not. Let's compare it to GraalVM and see what we'll get in that case. Yep. So let's maybe make it a bit more interactive. How do you think? Will it be faster, slower second time? Just guess. Faster? Well, okay, because I'm talking about GraalVM, yeah, so it should be perhaps faster because I prepared for this talk. So how much faster do you think? Like 1%, 2%, 0.5%, I don't know. 50%. Okay, you're optimistic, I like it. 20%. Any more guesses? Once again, 5? Okay. That's something, I know, maybe more realistic because as compiler engineers say, even if you get a few percent, that's a lot because on the scale, you know, where you have a lot of machines running, that would mean a lot for you. So let's maybe see, I think it should be complete by now. So it's 9 this time. Do you remember how much it was the first time? Yeah, it was, I think, 172. Where is that? Yeah, thank you. So it's, yeah, maybe it is around, I don't know, 18x, 19x. But here I have to say this disclaimer. So these are like example numbers, and you need to try it on your actual workload because it may differ. But yes, speedups like this are possible, and it will strongly depend on the code that you write, on the code that you use. So the numbers will be different in each particular case, and we always ask people, please download it, try it, compare it, and then like maybe make some conclusions based on the actual numbers that you get. So let me go back to the presentation. Yeah. So talking about measuring performance, it's not easy, and it's something that perhaps everyone should done on the actual workload and the actual application that you are working on. To prove this point one more time, here is a benchmark suite called Renaissance Dev, and those bars here, it's comparison of GraalVM compiler in both edition, like Enterprise Edition and Community Edition. That's the comparison over C2. And the red ones are GraalVM Enterprise Edition, the gray ones are Community Edition. So you see that in most cases they are somewhat better than C2. There are a few small cases where C2 is like comparable or slightly worse than C2. But on average, you can get like very different speed up. It can be, 20%, 50%. So you need to measure to get the exact numbers, and then you can make some conclusions about your particular use case. Moving on next, talking about Java programs fast startup. So GraalVM can offer you this great capability of compiling Java applications ahead of time. And the reason why this could be interesting for you is because those final binaries will no longer depend on the JVM. So all the code that needed to be for your application to be run will be right inside with a small implementation of virtual machine called Substrate VM. So it will be a fully independent, platform-specific binary that you can run and do the job that your normal Java application would do. Yeah, so from the inside, it looks like this. So normally, your Java code will be dynamically executed, and the hotspot itself will be the compiled part. But in the case of GraalVM native images, everything is precompiled. Everything will be in that resulting binary, and you can run it and get the same output as of just-in-time compilation with your Java application. From the inside, it works like this. So we analyze your application starting from the main method. We analyze what is reachable from there. we do this over and over again until we find all the classes that are needed for your application to run. And in the end, we optimize, inline all of that, and compile down to this one single binary that will be available in the end. Also, it has this, what we call image heap, which is kind of snapshotting your heap. So you can start with the pre-initialized classes, and that's one of the features that provides this fast startup. So in the end, you will get this one binary that will do exact same thing. And to show it to you once again, so another demo that I have here is this one. So what I have here is a simple Java program. Here is what it looks like from the inside. It basically just walks a directory, looks for the files, collects the information about size and amount, and outputs that to the screen. So what I can do with it is, as I have this listdir class here, with the native image tool, you can compile it to a native binary. You just feed this file to our native image utility. So it will start building, it will start analyzing all of that I mentioned, like analyzing what's reachable, looking for even more classes, inlining, optimizing code, and writing down to the disk. That is what it will do. You see that currently it's inlining, and a few of the next steps will be actually optimizing and providing the binary. By the way, today morning there was another presentation about, I think, the exact this capability of GraalVM by my colleague Tom. So if you were not there, I recommend checking the recording. He was showing some interesting use cases for serverless workloads. So you see that now I have this listdir file over here, which is the precompiled version of my application. And if I want to compare the performance, I would do like this: time Java and my Java, like just-in-time compilation mode. So you see it have found 8 files, and here is the total size, and this is the matrix of the time that were used. If I do the same just with the native binary, so I will get the same result. Yeah, so once again, 8 files and some total size, but the numbers will be order of magnitude different because it only has what it needs to start, so all the application code is available and it starts really fast. So talking about metrics a bit more. Yeah. Here are a few frameworks that provide you the ability to use GraalVM native images. So I just encourage you not to look at it as of frameworks comparison, but rather than comparison of just-in-time compilation mode present here in the orange and red bars, and ahead-of-time compilation mode present in this, light green one. So you see that in terms of startup time, AUT is so much faster because it doesn't need to do all this job of analyzing, optimizing code all over again at the startup of your application. So what's needed is already optimized and it's ready from the get-go. If you're talking about all the same frameworks, just from the perspective of the memory usage, once again, here is the comparison. So memory we use is so much less because we don't need all of that infrastructure anymore. We're just doing what your application is supposed to do. So currently, talking a bit more about our performance dimension chart. Currently, our AUT, our native images are like this. So we offer good startup. We offer you ability to save some memory usage, but in terms of peak throughput and in terms of working with latency, we are not quite there. But we would like it to be like here. So we would like all of that dimensions to be maximized so you can use all of that and don't have to you wouldn't have to trade off between them and think what you would rather like to use. So there are a few ways of how we are working on it. One of the ways is with profile-guided optimizations. So we are using, the reason why Java in this normal JIT compilation mode is so good for optimizing peak performance is because profiling information is available. So as your application is running, Java JVM can record its behavior, understand its behavior better, and based on that, optimize code for the exact behavior of your application. With our native image, normally it's a closed world assumption. So meaning at the image build time, when you only generate the image, all of that information is not yet available because application hasn't run yet. Yes, because we first build the image and then we run it. So what we can do, if we can collect the profiles of how your application behaves and feed it to our native image utility, we can kind of have this information from the future about application behavior. We can optimize based on the exact your application profile. And you can enable it like this. One more thing, if we are talking about improving native images, is that there are some things for native images where additional configuration will be needed. So, for example, if you would like to use reflection, if you would like to use some other dynamic things, you would need to provide us this configuration file and let us know about those abilities that you would like to use. You can use it manually, so you can provide those files for us, or there is a thing called tracing agent, which will record these things for you and will automatically output the files that we need so that we can optimize native image for these resources usage. So if you would like to understand a bit more about native image, because it's a huge topic and it's not like time-wise good to talk about all of it, there are a few resources that I recommend. First of all would be a reference manual where you can get access to all the flags, all the possible tunings, and all the capabilities of native image. Another one would be improving performance of GraalVM with profile guided optimization. This is available as an article in our Medium blog. And one more would be one of the recent talks from our Substrate VM team lead, Christian Wimmer from Code One. So that's exactly the talk where he is talking only about native images, where it's currently, what is the roadmap, and so on. So that's really interesting. I recommend watching it. And that's not it. GraalVM can also offer you, as I've shown this chart with different languages, GraalVM can offer you polyglot capabilities, something that during the break some of you were asking me about. So this is how it looks. So you can use different languages, like for example, in this case, Java, JavaScript, and R, which outputs this plot chart here, and they will all work nicely and fast together. Another one, and a pretty crazy one, is that there is some ongoing work to make GraalVM available for cross-platform development, so that you can even develop apps like for iOS and Android and so on with GraalVM. And there is some interesting case. For example, I've seen iOS application developed on GraalVM and like working on iOS device. So that could be another interesting direction to work on. And one more thing is industry use cases. So maybe you have seen Chris at this conference giving keynote and also having one more talk, I think, right before this one. So they are using GraalVM compiler at Twitter for their Scala microservices. They're using Community Edition, and they are getting quite fascinating speed-ups and reduced garbage collection out of it. Another interesting use case, and that's one of the most recent ones, is Oracle Cloud Infrastructure. So it has several services that used to be working on Java, but currently they made this migration to GraalVM. And as they said, the migration was very easy because you don't need to adapt your application to work on GraalVM. What they got in the end was peak performance was plus 10%, and garbage collection time was reduced by 25%, which is a lot, once again, on a scale where you have a lot of machines working at the same time. And one more interesting announcement from this year's Code One is that you can now also use Codecs Libraries to access GPUs from your GraalVM applications. There are some demos available that you can play with and see how that works for your application. And what is next? So I'd like to talk a bit more about one of the recent releases. So the recent one was, that's not what's coming next, so you can the next one would be what's coming next. So what was the recent release? For example, there were some updates to profile guided optimizations to make working with them more comfortable for you. Another one is that we now support the Java flight recorder snapshots in our GraalVM Visual VM, so you can have better understanding of your application, performance and diagnose and profile it better. Another one is some throughput improvements for native images because we want to maximize all of the performance dimensions for native images. Also, we added a thing called LLVM tool change so that working with LLVM languages is now easier in GraalVM. You can also use our plugin for Visual Studio Code, which is still a preview version, but maybe you'd like to try it. And yeah, there were some changes to class initialization in native images, which are by default now initialized at runtime, but with specific options, you can move it to the image generation time. What's coming next? So many people have been asking us about JDK 11 builds, and we are currently planning to deliver those in the next release, which is 90.3 around mid-November. Also, we are working to support more platforms, so ARM64 and Windows. Actually, for Windows, we already have some preview builds, but they are not complete yet. We are working on finalizing that one. Also, we are working on new, more advanced garbage collector for native images so that you can have improved, once again, performance characteristics in native images. A few more things is that we are working with community to implement important libraries and languages, and we see new languages being added on GraalVM because it's relatively easy to implement a language on top of GraalVM platform comparing to implementing it from the ground up. And yeah, if you see, once again, something you would like to see in GraalVM but hasn't done yet, you can also contribute, and you would like to see your contribution, be a welcoming contribution from companies, from individuals. It's very important for us. Where you can proceed, so first of all, you can download it and try it. It's not so hard. And also, if you are not up to downloading another distribution, you are more on the conservative side of things. If you're using Java 11, for example, you can try GraalVM compiler right in there. It is available through enabling experimental options, enabling JVM CI, and you can try not all of the capabilities, but the compiler right in your Java 11. Also, you can follow updates. We are very active on Twitter, but perhaps the best channel for following. And if you have some questions, we have those Gitter rooms with our team members where you can ask a question and somebody will help you. That's it on my side. If you have any questions, please ask those. Also, I have some GraalVM stickers. So if you like GraalVM or if you just like stickers, come and grab some. And thank you for your attention.